Let's start friction. So we have a mass here, it's on a horizontal surface. The mass is 5 kilograms, consider G to be 10 meters per second squared. And let's say that the mass of, the coefficient of static friction is 0.4, while the coefficient of kinetic friction is 0.2. So what does this mean? Right, so the forces are these. The free body diagram says that the object, the point-like object here, has 4 forces. So it will have the force due to gravity, which will be mass times g, so in this case it will be 50 newtons. Considering that there are no other forces on the y-axis, the sum of forces should be 0, meaning that the normal force should equal the force due to gravity, and it should also be 50 newtons. That means that, and if we know the coefficient of static friction, that means that the static friction can go up to this, which is 0.4 times the normal force, which is 50, meaning this is 20 newtons. Well, the kinetic friction will be times the kinetic over normal force times normal force, which is 0.2 times 50, and that will mean 10 newtons. So the static friction can get values from 0 to the threshold, which is in our case 20. What does that mean? That means that if my force goes up to 20, if it's 1 newton, 2, 3, 10, 15, 16, 17, 18, 19, up to 20, the static friction will be exactly the same like my force. So if my force is 5 newtons, friction will be 5. If my force becomes 10, friction will become 10, so it cancels it out. If my force becomes 15, friction will become 15. If my force, static friction, if my force becomes 20, static friction will be 20. And that's the highest value the static friction can get. So up to 20 newtons, friction manages to cancel my force. Now, if my force becomes more than 20, 20.5, then the object starts move, because friction can be no more than 20. So from that point on, my friction is stronger. So we start having acceleration, we start having motion, right? Now, automatically, as soon as it starts moving, friction becomes kinetic, so it becomes 10. So if I would make a table with my applied force and friction, so if my applied force goes from 0 to 20, the friction will be static and it will be exactly the same. But if my force becomes anything more than 20, 20.1, the object will start moving and it won't be static anymore. It will be kinetic and it will turn automatically to 10 newtons. From that point on, whatever my force is it 30? Is it 0? The friction, the kinetic friction, will stay 10 no matter what my force is. So apparently, if my force is stronger than friction, the object will accelerate, right? Let's say now that my force becomes 30 newtons. Well, I do see that a force of 30 newtons cannot be cancelled by the static anymore. That means that the object will start moving and the friction will become kinetic, so it will be 10. So if this becomes 30, I know automatically that this becomes kinetic and it will be 10. What does that mean about my acceleration? So now the sum of forces on the x-axis should create acceleration. Positive, negative, positive. So I have that my force minus kinetic friction equals mass times acceleration. So 30 minus 10 should be equal to the mass 5 times the acceleration, which means that my acceleration will be, in this case, 4 meters per second squared. Now, can they ask me about motion? Yes, of course they can ask me. Like when I know the acceleration is the link between the forces and the motion. When I know the acceleration, they give me, for example, the initial velocity, I can find the final, or I can find the position it will be, or how much it needs to speed up to a certain velocity. I can do, I can continue doing a kinematics problem from this point on. And we definitely have combinations of dynamics and kinematics.